When we say motion under gravity, and that too motion in one dimension, we had done in our chapter when we had dealt with motion under gravity, and over there we had solved the questions, we had solved the numericals using two methods. One is a normal way where we are taken when the velocity is increasing, we take acceleration as positive. When the velocity is decreasing, we say acceleration is negative. The second is we had dealt with the vectors, that is we have dealt with the velocity as a vector quantity, acceleration as a vector quantity, and we had used the sign convention and we have found the relevant answers. So over here once again we shall be using sign convention over here in projectile motion to understand and to apply the equations of kinematics. So let's once again review the sign convention. We say if from a tower a body has been projected up and the height of tower is, let's say we are taken as h, from this height h, just from the edge, a body has been projected up with the velocity u. So it goes up, it comes down. Let's take some values. Let's say height of the tower is 50 meter and this is projected up with 20 meter per second in the upward direction. And we have to find what is the time it is going to take to go from here to here to here, that is from A to C. What is the time of flight from A to C? This we have to find out. So over here what we do is we use the equation of kinematics with sign convention. And what does it say? It says if you are taking the vectors the upward direction as positive, so in the downward direction they have to be taken as negative. If in the upward direction you are taken as negative, so in the downward direction they have to be taken as positive. So if this side we are taking as positive, so then this side it has to be taken as negative. Certainly, that is they are opposite vectors. So obviously in equation of kinematics we shall be dealing with velocity, we shall be dealing with displacement, and we shall be dealing with acceleration. So these are primarily the three things we shall be dealing with. Time is a scalar quantity, so it doesn't have any direction. So if we have to apply the equation of kinematics from here to here, A to C, we can say S is equal to ut plus half at square. What is S? Now we are dealing with the vectors. We are dealing with the vectors. S is now not the distance, S is the displacement, and we are taking the journey from A to C. The journey starts at A and it closes at C. From A to C, the displacement we are talking about, displacement is the shortest distance between the initial point and the final point, and it has to carry an arrow on its head. So the displacement initial to final, it is not just like displacement, it has to carry arrow also in this direction, that is initial to final. The length of this arrow is 50 meter only and it is in the downward direction. Downward direction we are taking as negative, so the displacement vector from A to C is going to be minus 50. U stands for initial velocity at the initial point, that is A point. At A point it is 20 meter per second in the upward direction. In the upward direction it has to be taken as positive, so we say plus 20t plus half acceleration. Over here acceleration is acceleration due to gravity, and we have done it earlier also and in laws of motion also, that is whenever you throw a body in the upward direction, whether it is going this way, this way, this way, the earth is applying a force mg in the downward direction. Force is equal to mass into acceleration, so acceleration is always g in the downward direction, that is acceleration vector is in the downward direction. Whether the body is going up or whether the body is coming down, the net force onto it which is being applied by the earth is always in the downward direction. So it means the acceleration vector, it has to be in the downward direction also. So it means when the acceleration is in the downward direction, it means it has to be negative, that is let's take it as minus 10 meter per second square into t square. So from here we can get the value of t. One of the values of t, it may be negative, and obviously in this case time cannot be negative, so we will take the positive value and we will reject the negative value, and this way we can directly, just by writing one equation, we can get the value of time. Many times students get confused when to take the displacement vector as positive and when to take it as negative. To find when to take the displacement positive, when to take it as negative is simple. We just have to remember that is in which direction we are taking it as positive and in which direction we are taking it as vectors as negative, and that is our discretion. If we are taking vectors in one direction as positive, then the opposite direction we have to take it as negative. Like if we take the vectors in the upward direction as positive, so in the downward direction we shall be taking it as negative. So if this way we are taking it as positive, then this way we have to take it as negative. Now let's say we have this x coordinates and we have this y coordinates. So this is xx dash, this is yy dash, and over here we have our origin. And let's say our body has been projected from here and it goes to this point. So this is initial point of observation, this is final point of observation. If someone says what is SY, so SY means that is how much body has gone up or down from the initial level. And when we say what is displacement along the x-axis, over there we are bothered about how much the body has moved in the forward direction or in the backward direction. When we are bothered about the displacement along the y-axis, we shall not be bothered about the motion along the x-axis. When we are bothered about the motion along the y-axis, that is what is the displacement on the y-axis, it means the initial level is this, the final level is this. So this is the displacement on the y-axis, that is the body has moved up from this level to this level. So displacement on y-axis is this much, and this is going to be positive. Had the body gone from B to A, then it means from this level it has lowered itself to this level. So displacement on y-axis is from here to here, that is it is going to be negative. If someone asks what is the displacement along x-axis, so it means we are bothered that is from here x coordinate, it has gone to this x coordinate, that is the Sx is going to be in this direction, and this is going to be positive because this way we are taking it as positive. If we take the case of, let's say from a tower, this tower which is 100-meter high, a body has been projected like this and it goes and falls over here. Let's say at a distance of 50 meters from the base of this tower. It is projected from here and it strikes at B. So if we have to find what is the displacement on the y-axis, we see what is the final point of this body which has been projected from here, and it is over here. Along the y-axis, if we are bothered about just along the y-axis, so it means we are talking the two levels. The initial level is over here, the final level is over here. Final level is below the initial level, and this level is below this much, that is 100 meters in the downward direction. So in this case, when the body has gone from here to here, so the displacement on the y-axis, we are just bothered about the y-axis. We are not bothered how much forward or backward it has gone. We are just bothered about that is how much it has gone up this level or below this level. So it has gone below this level by 100 meters. So SY is going to be 100 meters in the downward direction. Downward direction is negative, so it is going to be minus 100 meters. And if we are bothered what is the displacement of the x-axis, now we are just bothered about how much it has moved in the forward direction or backward direction. Now we are not bothered how much it has moved up or down. So from this level, from x coordinate, from here to here it has gone. So Sx is in this direction. In this direction we are taking it as positive. So Sx is going to be plus 50 meters. Now suppose a body has been projected from here. It goes from here to here and comes back. Then in this case, Sy is going to be equal to 0 because the initial level and final level, they are at the same level. The displacement between A and C along the y-axis, that is equal to 0, or rather for that matter, Sx, that is also equal to 0. So this way we can use the equations of kinematics and we can use the sign convention to get the answers. So this is how we shall be using the equations of kinematics with sign convention in understanding of our topic projectile motion.